My dear students, welcome to chemistry class. In the previous video, we have discussed about the structure of oxides of nitrogen. The first type, that is nitrous oxide, formula that is N2O. The structures, Lewis structure, we already discussed. This video also we will discuss about structures of oxides of nitrogen. That second type, that is nitric oxide. Nitric oxide, formula is NO. Okay, this is number 2. Nitric oxide, the formula is NO. So, you already know very well about how to draw the Lewis structure. For that, first step, you have to calculate the total number of valence electron in the compound. So, NO, nitrogen valence electron 5, then oxygen valence electron 6. So, total number of electrons present in this NO, nitric oxide, 11 electrons. Okay. Now, write the two atoms, nitrogen and oxygen. Then after that, draw one bond, single bond between the two atoms. So, nitrogen, oxygen, between that one chemical bond. This bond contains 2 electrons. Okay. Bond contains 2 electrons. Now, we have total number of electrons 11. So, out of 11, subtract these 2, you will get 9 electrons. Clear? Now, you have to distribute this 9 electron to the atoms. So, first you have to give to oxygen, preference to oxygen. So, here 2 electrons. Now, remaining, actually this oxygen will contain octet, that is 8 electrons. So, 2, I am writing here 6 more electrons, 2, 4, 6. Okay. So, now total number of electrons, how much? Here 2, 4, 6, 8. 8 electrons completed. Okay. See, now out of this 9 electrons, 6 it is already shared. So, 9 minus 6, remaining 3 electrons. These 3 electrons will go to nitrogen atom. So, 2 here and one more electron here. Now, check the octet. For oxygen, the octet is completed 2, 4, 6, 8. But the nitrogen is not completed. It's 2, 4, 5 only. Okay. So, what this oxygen can do, this lone pair electrons, it can be converted to bond pair electrons. Okay. So the structure, see the structure, nitrogen, oxygen, 2, 4. Between this nitrogen and oxygen, double bond due to the shifting of this lone pair to bond pair. Nitrogen here 2, here 1. Okay. So, this is the correct structure for this nitric oxide. How we are checking the correct structure? Calculate the formal charge. Formal charge. You studied formal charge in class 11. You check how to calculate the formal charge. If you calculate that both atoms, not only both atoms, all the atoms, the charge must come 0, then it's said to be is a correct structure. See, in this structure, this is the correct structure according to the formal charge. Okay. Now, so this much is enough. Actually, here one electron is here in the nitrogen atom. nitrogen atom, actually it has 2, 4, 6, 7 electrons are here. But oxygen 8 electrons completed. So what this one electron can do? This electron can transfer to oxygen. This nitrogen can donate this one electron to the oxygen atom. Also, what will happen? See here, nitrogen, oxygen. Here this oxygen can contain extra one electron due to the transfer of one electron to oxygen atom. This is excess electron. Okay. Also this oxygen can donate this excess electron to nitrogen atom. Right. So that we can represent the structure like this: nitrogen, double bond oxygen, the shifting of electron from nitrogen to oxygen or oxygen to nitrogen. The distance between this nitrogen and oxygen is 115 pm, picometer. Okay. So that's all about the structure of nitric acid. First calculate that valence electron, total number of valence electrons, write the atoms, make single bond, then share the electrons to the oxygen atom. Then oxygen atom will contain 8 electrons. Then check the remaining electrons for nitrogen. Actually this nitrogen 7 electrons are remaining. One electron it can be transferred to oxygen atom, and oxygen atom will get one excess electron. This excess electron can also transfer to nitrogen atom. So this is the structure of nitric oxide. Okay. Next structure, that is dinitrogen trioxide or nitrogen sesquioxide. Number 3, dinitrogen trioxide or nitrogen sesquioxide. The formula is N2O3. Clear? Now draw the Lewis structure. See, N2O3, how many electrons, valence electrons? There are 2 nitrogen atoms plus 3 oxygen atoms. Okay. So 2 into nitrogen atom, it contains 5 electrons, valence electrons, plus 3 into 6 valence electrons, equal 2 into 5 10 plus 3 into 6 18, total 28 valence electrons. Okay, 10 plus 18 28 valence electrons. Now write that as atomic symbols: nitrogen, nitrogen, oxygen, oxygen, oxygen. See, 3 oxygens, then 2 nitrogen atoms. Now draw single bond between all the atoms. Single bond, single bond, single bond, single bond. Okay. Now check this, all the single bond together 8 electrons. So 28 minus 8 equal 20 electrons are remaining. Now these 20 electrons you have to share between the atoms. So for oxygen, give the preference. Here 2 electrons already present here. So remaining 2, 4, 6. Then 2, 8 electrons. So oxygen octet completed. Now next oxygen, 2, 4, 6. Then 2, 8 electrons completed for this oxygen. Now remaining, so this 6 plus 6 is 12. Then 2 electrons here, 2 electrons here, 2 electrons here. Total 6 plus 2, 8 electrons. For oxygen, all the 3 oxygen octet is completed. So 3 into 6, 18 electrons. So out of 20, 18 electron is completed, remaining 2 electrons. These 2 electrons you can share for the nitrogen atoms. So here 2 electrons, right? Now check octet for this nitrogen atoms. For this first nitrogen atom 2, 4, 6 only. This second nitrogen atom 2, 4, 6 electrons only. So this lone pair can be converted to bond pair. Okay. Then here also this lone pair can be converted to bond pair. Okay. So how the structure will form? Nitrogen, and here nitrogen, oxygen, here oxygen, here oxygen. Because of this shifting of lone pair to bond pair, here it will come double bond, here also double bond. Okay. Now write the remaining electrons 2, 4, 6, then here 2, 4, then here 2 electrons. Now check the octet for this oxygen 4, 4, 8 electrons, here 6 plus 2, 8 electrons, here 4, 4, 8 electrons. For nitrogen 2, 4, 6, 8. So this nitrogen octet is completed. For this nitrogen octet is completed. This also you see 2, 4, 6, 8. Octet is completed for this nitrogen also. Okay. So this is the correct structure for this dinitrogen trioxide. So apply this formal charge. When you apply formal charge, this oxygen will get negative charge and this nitrogen will get positive charge. Okay. That resonance structure for this, it can come like this. Nitrogen, this oxygen double bond O, then nitrogen, here it can come double bond O, and here single bond oxygen. Okay. So here negative charge and here positive charge. This is the resonance structure for this nitrogen dinitrogen trioxide. Understood? So N2O3, calculate the total number of valence electrons, then draw the structure, nitrogen, nitrogen, then 3 oxygens, then share the electrons to get octet. Then after that apply formal charge, here minus, here this nitrogen plus. This resonance structure also it can come N double bond O, then N double bond O, then here single bond O, then this oxygen will get minus, nitrogen will get plus charge. This is the structure for dinitrogen trioxide. Okay, students. So now next structure, there is nitrogen dioxide, NO2. That fourth one is nitrogen dioxide, NO2. Okay, students. Then NO2, calculate the valence electrons. 5 plus 2 into 6 equal 5 plus 12, that is 17 electrons. Okay. Now draw the structure. Nitrogen, one oxygen this side, another oxygen this side. Now make single bond between these two atoms. Now remaining how many? 17 minus 4 equal, there is 13 electrons. Okay. So out of these 13 electrons, distribute that 13 electrons on both oxygens to get octet. Here 2, 4, 6, then 13 minus 6, remaining 7 electrons. Then this 7 electrons Then here distribute 2, 4, 6. Now 7 minus 6, 1 electron is remaining. This 1 electron, it will go to this central atom, nitrogen atom. Okay. So 2, 4, 6, this oxygen 8 electrons completed. Then you see this side oxygen also 8 electrons completed. Now here this nitrogen has to complete octet. For that this lone pair can be converted to bond pair. Then that structure, it can come like this. Oxygen, nitrogen, then oxygen. So here double bond because of the shifting of lone pair to bond pair. Then here single bond. Now here 2, 4 electrons, here 2, 4, 6 electrons, clear? And here 1 electron is remaining. Now you see here nitrogen 2, 4, 6, 7 electrons, 1 electron is remaining here. Okay students. So this is the structure of nitrogen dioxide. Calculate the valence electrons, distribute equally. So to get octet electrons, we will get this kind of structures. Next one is nitrogen tetroxide N2O4. Next structure. Structure 5. Nitrogen tetroxide. Tetra means 4. Formula is N2O4. N2O4, calculate the total number of valence electrons, 2 nitrogen atoms plus 4 oxygen atoms. Then how much it will come? So total 2 into 5 plus 4 into 6. So 10 plus 24 will get 34 electrons. Okay, 34 valence electrons. Now write the symbols. 2 nitrogen atoms, then 4 oxygen atoms. So 1 oxygen here, 2, 3, 4. Okay, so 2 nitrogen atom, 4 oxygen atom on the surrounding. So now make the single bond between all the atoms. 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. So 5 into 2, 10. So 34 minus 10, remaining 24. Okay, 24 electrons. Now distribute electrons equally. Here 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6. Now 24 minus 24, there is no electrons. There is no remaining electrons. 0 electrons is there. Now you have to check the octet. 4 oxygen, octet is completed because 6 plus 2, 8, 6 to 8, 6 plus 2, 8, 6 plus 2, 8 is completed. Now go to nitrogen atom. Nitrogen atom, how it can come for this nitrogen octet? This electrons, lone pair electrons can be shifted to bond pair. Here also lone pair can be converted to bond pair. Then what will be the final structure? See here, 2 nitrogen atom, then oxygen atoms. Okay. Now here it will come double bond, single bond, double bond, single bond, single bond. Okay. Then that write the electrons. 2, 4, 6, 2, 4, then here 2, 4, 2, 4, 6. Now check all the atoms whether that octet is completed. See here, this for this oxygen atom 2, 4, 6, 8. This also 2, 4, 6, 8. 8, 8. So oxygen is completed. Check for nitrogen 2, 4, 6, 8. This nitrogen 2, 4, 6, 8. So nitrogen tetroxide is completed. Structure is completed. So this is the way you have to draw the structure for the nitrogen tetroxide. Clear? Now next oxide is nitrogen pentoxide. Number 6, that is nitrogen pentoxide. Formula is N2O5. Right? Then N2O5, there are 2 nitrogen atoms, then 5 oxygen atoms. Then total valence electrons are 2 into 5 plus 5 into 6. So 10 plus 30, there will be 40 electrons. Okay. Now next step, draw the write that symbol of atoms. Here I am going to write oxygen in the middle, then both side nitrogen atoms. Then there will be 5 out of these 5 oxygen atoms, one is already present here. Then oxygen, 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 oxygen. So total 5 oxygen atoms. Okay. Then 2 nitrogen atoms. Then draw single bond between all the atoms. Now you check that remaining valence electrons. Now out of this 40 electrons, right here, 40 minus 1, 2, 3, 4, 5, 6, 12 electrons. So 28 electrons remaining. Okay. Now these 28 electrons have to distribute equally for all the atoms to get octet structure. Then oxygen 2, 4, 6. This oxygen 2, 4, 6. Here 2, 4, 6. Then here 2, 4, 6. So 28 minus, there are 4 oxygen atoms, 4 into 6, 24 electrons. So 24 remaining, 4 electrons are remaining. These 4 electrons will go to this oxygen atoms. So 2 here, 2 here. Okay. Now check the octet for all the oxygen atoms and nitrogen atoms. This oxygen atoms 6 plus 2, 8 completed. This oxygen atom 6 plus 2, 8 completed. Then here 6 plus 2, here also 6 plus 2, 8 completed. In the middle also 4 plus 4, 8 completed. Now check for nitrogen atom. Only 6 electrons are here. Here also 6 electrons. Then what it will come here? Then this electrons, lone pair electrons can be shifted to bond pairs. Then this also can be shifted to bond pairs. Then final structure, that is, now the final structure, that is nitrogen, oxygen, nitrogen, oxygen, oxygen, oxygen here, oxygen here. Here it will come double bond, single bond, double bond, single bond, single bond, single bond. 2, 4 electrons, here 6 electrons, then here 2, 4 electrons, here 6 electrons, then here 2 electrons, here 2 electrons. So that's all about the structure of nitrogen pentoxide. Calculate the total valence electrons, then write oxygen in the middle, then nitrogen, oxygen, then make equally. Here also, after that shifting of lone pair electron to bond pair, you will get this final structure. That's all about the structures of oxides of nitrogen. Next, we are going to see about structures of oxacids of nitrogen. So after these structures, we will study about structures of oxacids of nitrogen. then preparations of oxacids of nitrogen. Okay. So now students, structure of oxacids of nitrogen. Structure of oxacids of nitrogen. Okay. So there are some types of oxacids are there. That first type is hyponitrous acid. Name, I am writing here name, then formula, then structure. The first name is hyponitrous acid. Hyponitrous acid. That formula is H2N2O2. H2N2O2. See here, hypo, it means that oxidation state is +1. This hypo means oxidation state, that is ON, that is +1. This nitrogen oxidation state is +1, so that we are calling hyponitrous acid. That structure is very simple. So there are two nitrogen atoms, nitrogen, one side OH, another side OH. Okay. Between this single bond, and here double bond. Okay. How these structures, already in that previous topic, that is structure of oxides of nitrogen, I explained all the structure with Lewis structure. Okay. Each and every types I explained with Lewis structure. Here also apply this Lewis structures, you will get this correct diagram. Okay. It's very simple. Use this Lewis structure, you will get this diagram. You try, you will get it. Then second type, that is hydronitrous acid. Second type is hydronitrous acid. That formula is H4N2O4. See here, between this nitrogen, double bond is here. This double bond will be open, and there will be two more OH atoms will be two more OH group will be added. See the structure: nitrogen, OH group, here OH, here OH, here OH. That's all. This double bond is opened, and two more additional this OH group comes. So this is the structure of hydronitrous. Hydro means water, that is OH group comes. Then next type, that is nitrous acid. Next type is nitrous acid. Nitrous acid formula is HNO2. Then the structure will come like this. So try this Lewis structure, you will get easily. Here nitrogen, double bond O, that electron 2. Here you will get nitrogen 2 electrons, and here 4 electrons. This is nitrous acid. Okay. HNO2, the formula is HNO2, structure is HONO. HNO2. Okay. Next one is pernitrous acid. Pernitrous acid. Pernitrous acid, that is formula is HOONO. HOONO. See, actually this per means addition of one oxygen atom. Okay. See, water, that is H2O, then peroxide, that is H2O2. So addition of one oxygen atoms. Okay. Then structure will come like this: hydrogen, oxygen, then nitrogen, then oxygen. Here double bond will come, here one single bond, here 4 electrons, then here 4 electrons. So try this Lewis structure, you will get this structure. Next one is nitric acid. That formula is HNO3. Okay. Then that structure is nitrogen, oxygen, 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 hydrogen. Okay. Make a single bond. So use this Lewis structure, you will get this type of structure. Apply formal charge, you will get the correct charge. Okay. Then last type is per nitric acid. Per nitric acid. So already told you the per means addition of one oxygen atom, that HNO4. Okay. Then the structure will come like this: oxygen, nitrogen, here oxygen, then in between one oxygen, here OH, then here N plus double bond, then here single bond minus. Okay, so that's all about all the structures of types of oxacids of nitrogens. So this much is enough for a structure of oxacids of nitrogen. Okay students, hope you understood today's lesson. In case if you have doubt, you can contact me. So thank you very much students.